Alright, so welcome to How to Motion Map. Okay, again, we're in Unit 2, and I want to direct you right away. But not only am I going to kind of talk you through this, but Mr. Andrink and I have also posted on your course website a whole piece of literature with motion map reading. Okay, so that's located here, and it's going to talk about everything that I'm going to talk about. Okay, I would definitely refer you to that. Okay, again, it's under Unit 2, down below, called motion mapping. Okay, anyways, here are some notes that are supplemental to what's there. And I'm also going to talk you through a couple different pieces to that. Okay, so first things first, how to motion map. Okay, when we motion map, pretend that there's a strobe light going. Okay, object moves, and every time that strobe light flashes is in 1 second intervals. Now, when that strobe light flashes, it shows you the location of the object at that period. Also, when things are moving at a certain velocity, you know, when a strobe light goes off, there's a streak that follows behind them that kind of shows you, is this object moving quickly or is it moving slowly? Okay, so each time we draw a point is like when the strobe light goes off, and that point represents the object's location at that time. Okay, and that's the second part then. So as we draw these motion maps, the points that we're drawing represent the object's location at that exact time. Okay, moreover, like I said, when an object's moving and a strobe light's going off, you can kind of see the streak following behind it. If it's moving fast, there's a larger streak. If it's moving slower, there's a smaller streak. I guess you can also think of it as cameras that have a slow exposure lens. When the lens opens, if the object's moving fast, like I said, there will be large streaks following it, and if it's moving slowly, smaller streaks or a smaller streak behind it. So the second thing is we're going to be drawing arrows that will show the object's velocity. Okay, so like for example, here is an object that's moving in the constant positive direction. Okay, we show that it's constant because these arrows are exactly the same, and it's moving in the constant positive direction for 3 seconds. Okay, we know that because when you look, 1 point, 2 points, 3 points. Okay, another example, an object moving at the constant positive velocity again, but it's a larger constant positive velocity. And again, if you have two different motion maps that are both constant positives, we'll typically use these congruent marks like you see in math class. So that's just showing the double tick on each of these is showing that all of these are the same. The single tick on these is showing that all of those are the same. Okay, again, larger vector, like we said above, means larger velocity. Okay, here's an example of an object not moving. 3 points in a row means the object's not moving or the velocity is 0. Now again, when we do this, notice that these are usually put on a number line, and I kind of did a bad job representing this, but the number line represents position. So let's say this is position is 0, this is 5, this is 10 meters. Okay, when we show an object not moving, we stack the points on top of each other because if it's not moving, we have to show that it's staying at 0. Okay. Lastly, here's an object moving in the constant negative direction. Okay, and again, there should be a number line here. Okay, and each one of these represents a distance that it's traveling. Okay, if this is 0, this would be -5, maybe negative 10. Okay, so wanted to show you guys that. Now, let's look at some examples, and I'm actually just going to steal right from your packet. Okay, I know you guys have seen this already. This is from worksheet 2. Here's an object, constant positive slope means it's a constant positive velocity. Okay, real quickly I'm going to figure out the slope here. Rise over run, or position divided by time, so it's 2 meters. It looks like in 2 seconds. So that means I'm traveling at positive 1 meter per second. Don't forget that. Slope takes us to velocity. Now if I want to motion map this object, okay, I'm going to look at my graph and I'm going to see, well, 1, 2, 3. I have 4 seconds I need to motion map for. Okay, so I'm going to know that I have to draw at least 4 points. Okay, I know my total distance this object is going to travel is 4 meters, so I'm going to need to have 4 meters available on my number line. So this is we'll call this -1, 0, 1, 2, 3. Here's 4. Okay, and it should be a constant positive velocity, so I should show that. Okay, object starts at 0, so my first point is going to be at 0. Okay, at the first second, or at the beginning of the first second, the object is here, so I know it's moving in the positive direction. At second 2, it's moving here. And then the last one is going to be at second 3, moving because I know at the end of second 4 will be there. Okay, need to show that this is constant and positive. There it is. And again, if you're looking at this, the position change from 0 to 1 in 1 second is 1 meter. 1 meter per second. That's what we figured out there. Okay. There's one example. Here's another one. We'll get a little more intricate with it. Okay. Here's your position versus time graph again. I'm just going to quickly translate that to velocity versus time graph. Okay. So here we have a positive 1 slope again, which means we're moving 1 meter per second for the first 2 seconds. So I'm going to go ahead and draw that here. Okay. And then I have negative 1, 2, 3, 4 in 2 seconds. So that means I'm moving at negative 2 meters per second for the last 2 seconds. 1, 2, like that. There's my graph. Now I know, again, I'm going to take a look at, what I need to have to be able to draw my motion map. Here's my number line. Okay. The object starts at 2. I have 4 total, and I have 4 seconds of movement. So I need to go 1, 2, 3, 4. I'm going to make this point 0 here. Okay, so this is 1, 2, 3, 4, and we're going to say that's in meters, just like it is above. Okay, object starts at 2. Okay, moves in the constant positive direction at 1 meter per second. So 1 second, 2 seconds, constant positive, and then the object moves in the negative direction at negative 2 meters per second. So now we're going to turn around and it's going to go back the opposite direction. Negative 2 meters, right? Negative 1, negative 2. So here it is after that second, and after the second of negative motion, we should be back to 0 based off of this, and sure enough, that's where we are. Hopefully that's a good introduction for you to motion mapping. Again, just to summarize and go back to the notes. Okay, each point represents 1 second. Pretend it's like a strobe light or a camera flash every single second, and wherever that object is located, that represents where it is in time. Okay, draw your arrows. The vectors represent velocity. Again, some things to refer to: constant positive, larger constant positive. When an object is not moving, we stack the points like that at 0. Okay, that's showing a velocity of 0, and then we can also have negative velocities. Thank you for watching How to Motion Map.